Hello everyone, I am Saujanya. I am from Sri Venkateshwara College of Engineering. Today we are discussing about the automata theory of compiler, and we can discuss about the minimization of DFA. It has three types: definition, algorithm used, example problem, and we can discuss about the definition of minimization of DFA. It has two states: PQ of DFA are equivalent and it is also distinguishable if and only if PQ and QW are leading to final states, or and also PW and QW are the leading to the non-final states. These two are the non-final states which is leading to it. And we can see the algorithm to find the equivalence of DFA, which can be used. Remove all non-reachable states for start state, and also for each part P and Q, where P belongs to Q and Q belongs to Q. If P belongs to F, then it is the final state, and Q doesn't belongs to final state, or P does not belongs to F and Q belongs to F final state. Then mark the pair of P and Q has X in the table, and also it has the each pair for P and Q for each symbol and belongs to find alpha of P and Q is equals to R, and also it has the Q and A, then S. If the pair is R and S, then mark it the table, then mark the pair. It has the two pairs of the P and Q, which is marked in the table of pair P and Q, and also it will repeats the step 3 until none more marking can be made, and it is a combine unmarked states. Example problem as shown in the figure. Step 1. Remove non-reachable states for start state, and that is removed Q3 because it can't be reached for Q0 starting state of it. And step 2, as shown in the figures, draw a table and mark X where PQ contains one final and one non-final states. If that so marked, P, Q are X. P is of one final state and Q is the one non-final state. Has X, that is the P is the final and Q is the non-final. And also let's take Q0 and Q1. Q1 is a final state and Q0 is a non-final state as per the algorithm. So let's mark it as a X. Now let's take Q0 and Q2, and Q0 is a non-final state and Q2 is a final state, so it has a X. Now let's consider Q1 and Q2, both are the final states, so we cannot mark it as the final state. And next we can see the step 3 as shown in the figure. Q1 and Q2 is equals to Q1 and Q2, or alpha Q1 and Q2 is equals to Q1 and Q2. As per the algorithm, if Q1, Q2 is not marked, then Q1 and Q2 can't be marked in table, and also both are a final state, so Q1 and Q2 is not possible to mark in the table. And next we can see the step 4 as shown in the figure. Repeat the step 3 until no more marking can be made. As per the example, there is no marking can be done, so will be stopped. And step 5, combine unmarked states. Here the unmarked states are Q1 and Q2. Let's combine it. These are the examples for minimization of DFA. And what is the mean by minimization of DFA? It has the process of reducing given DFA to its minimal from is called minimization of DFA, and it contains the minimum number of states, and the DFA in the minimal from is called as minimal of DFA. And how to minimize the DFA, and it has the two popular methods for minimizing the DFA are, it has the two types minimize DFA methods, equivalence theorem and table filling methods. And minimization of DFA using equivalence theorem. Step 1. Eliminate all the dead states and inaccessible states for given the DFA, if any. Dead states, all those non-states which translate it itself for all input symbols in alpha are called as dead states. Inaccessible states are all those states which can never be reached from the initial state or is called accessible states. Step 2. Draw a state transition table for the given DFA, and transition table has shown the transmission of all states and non-input symbols in it. Step 3. Now start applying equivalence theorem, and it takes the countable variables and initial in with value 0 and divide set of states into two sets such as that one set contains all non-final states and other set contains all final states, and the partition is called as P0. Step 4. Increment k by 1. Find pk by partitioning the different sets of p k01 in each of set pk, and consider all possible pair of states within each set, and if the two states are distinguishable, partition and set into the different sets of pk. And step 5, as I told you before, it contains the repetition of step 4 until no changes of partition occurs. And also other words, when we find the value of pk is equals to pk1 as top. And step 6, all those states are which belongs to the same set as equivalence, and the set equivalent states are merged to the form of minimization of DFA. Minimization of DFA, it means the reducing the number of states from given FA. Thus we can get the FSM finite states machine with the radiant states after minimization of the frame. And also we can follow the few steps to minimize the DFA. Remove all the states that are unreachable from the initial state to via of any set of transition of DFA. And next, now split the transmission table into table 1 and table 2 contains all final states, and T2 are the non-final states, and find the similar rows in the given T1, and that means find the two states which have the same values of A and B and remove one of all them. And next is repeat the step 3 until we use the no similar rows available in the transition tables. And now repeat the step 3 and step 4 for the table 2 also. Combine to reduce T1 and T2 tables to combine transition tables in the transmission of minimization of DFA. And why we minimize the DFA? It means energy minimization is an essential to a determining the proper molecular arrangements in the space, since the drawn chemical structures are not energetically favorable. And what is a minimizing the function? Minimizing a function means finding the values of variables, says x, for which the function says f has minimum values. It can be found by these three simple steps: double derivatives test to find the derivative of functions df and dx and equating it as 0. And what is minimizing and maximizing? We can use to talk the maximizing and minimizing a function. What it means, what can do minimize the possible values of the function or the minimum possibles of the values of function. And what is minimizing sequences? A sequence of elements from set of M, which is corresponding sequence of functions values, tends to greatest lower bound. And thank you for watching this video.